See. Start this one. Hello, good evening, everybody, and welcome to our Tuesday evening, our technical Tuesday evening. We're starting a new series now after having a break last week. And tonight we're covering the part that we call our birthday suit or the tent of our structure, and that is the biggest organ in your body, namely your skin. So let me share my screen and get going. I'm doing a little bit of more technical stuff as usual just to get going, but you'll soon understand why I'm doing that, and it'll just give us a better idea of exactly what the skin does. We know it's this large part of the body, but what does it actually do? What is it there for? And how does it work? That's probably the more important thing. So your skin is the largest organ of the body. We know about all the other organs like the heart and the lung and the liver, but your skin is actually an organ as well. It just happens to be the outer part of the body, but it functions like pretty much any of the other organs. And it's also commonly known as our birthday suit because, well, that's what we're born with and generally what we go out with as well. So the skin is the largest organ of elimination in our body. So it is also a filter, very much like the liver and the kidneys. And the skin has remarkable elasticity. So we can expand and we can contract, and we often do without even noticing it. Now, as we age, not only skin elasticity changes, but we also lose flexibility in other tissues. And this is why, as we get older, when you hit your 90s, you're probably not going to be able to touch your toes quite as easily as you did when you were in your 40s and 50s. Looking at the importance of cellular nutrition, this can provide a better understanding of the significance of skin nutrition. So just like every other part of the body, the skin is obviously made up of a whole lot of cells. And just like every other cell in your body, it needs good nutrition. For those who were on last night's national, or should I say international talk on cellular nutrition, you will understand that. And we'll get into this a little bit later on as well. I think we're all familiar with this little picture of the unhealthy cell and the healthy cell. And this is really what your skin is made up of. An excess of artificial or altered fats in the cell membrane can cause a loss of water and dehydration. High-quality oils and antioxidants protect and build a healthy cell wall, preventing dehydration while permitting absorption of essential nutrients and efficient waste elimination. Again, this is exactly how your skin works. The skin operates much the same as the cell wall. So if you look at the skin as a very large version of the individual little microscopic cell, you'll get a better idea of exactly how it works. The rate at which the skin ages can be slowed by taking measures to assure continuous, adequate antioxidants. Obviously, being the outer part of the body, our skin is exposed to the most amount of oxidation because pretty much everything else that's underneath the skin is protected to a certain extent because the skin has to filter out all those oxidants before they get in, unless obviously you have the oxidants in your food. But for all the toxins in the environment that we're exposed to, that's where the skin works really, really well as an antioxidant. So the skin condition reflects the adequacy of the intake of fats and proteins, as well as the antioxidants to protect tissues. And this is why some people at a young age look very old, and some people at an old age still look very young. The skin is known as the integumentary system, and that protects our body from environmental damage. So if you think about our body being mostly water, what keeps the water in but allows some water out, but prevents us from getting all messy? Think of all the fluid on the inside of your body. If our skin wasn't working correctly and worked as a two-way system instead of just a one-way system, things could get rather messy, I think. Now, the skin forms a protective barrier, shielding your body from elements and pathogens, as well as performing several other vital functions. Again, here we come up with the organ. Organs do multiple number of different jobs, and the skin is no exception. The skin is essential to well-being as it helps to regulate the body temperature and contains many accessory organs such as nails, hair, and glands. The glands are usually very cleverly hidden. Things like your tear glands, for instance, are usually very cleverly hidden, but they are all there, embedded in the skin. The integumentary system is comprised of skin and its accessory components, including the hair, nails, and associated glands. The integumentary system performs several vital functions, and these include protection from pathogens, and this includes like toxins in the air, acid rain, and all those sorts of things. It balances fluid levels, because if we retain water, what happens? We swell up. And if you are not perspiring enough, you end up with things like heat stroke or heat exhaustion. So it needs to balance. We need to be able to perspire or sweat, but we also need to not do that too much. And that needs to be maintained in the system if we are dehydrating. And it stores fatty tissue for energy supply. It produces vitamin D, obviously with the help from the sun, because remember, vitamin D, although technically not a vitamin, it's more a hormone, but it's also known as the sun vitamin. It provides sensory input. Think about brushing over your skin. Can you feel it if you just lightly touch? Somebody lightly touches your skin, can you feel that? Or if they push hard, or you have something hot or cold put against there, your skin picks all of that up. And it helps to regulate body temperature. Again, we don't want to be too hot, but we don't want to be too cold either. If you had to slice down and use a microscope, this is pretty much what the skin looks like. I'm going to try and get my little cursor over here. So this is the outer part, which is known as the epidermis. And we won't get into all the little nitty-gritty and bits and pieces, but there's your epidermis. We've got the fatty layer over there. We've got a whole lot of blood vessels and things sitting inside over there. And, oops, sorry, I'm just going to mute over here. Yeah. Sorry, I'm picking up noise. There we go. Sorry. Galaxy, can you please mute? I'm not able to mute you over there. There we go. So this is a cross section, as I was saying. So you've got your little hairs, and even the hair has got blood vessels and all sorts of different cells and things. So while we look at the skin and we see the outer layer, obviously, underneath there's a whole lot of things that are happening over there, which is quite fascinating. As I said before, it is the largest organ, and it weighs approximately 9 kilos, and it covers an area of about 1.9 square meters on an adult. Obviously, some people have a little bit more weight in their skin, and some people have a little bit less, and some people cover a bigger or a smaller area, dependent on your body size. The cross-section of skin reveals the 3 layers, namely the epidermis, which is what I said is this part over here, the outer bit, the dermis, which is the next layer in, and then the subcutaneous fascia, which is the part that essentially between the skin and the muscle. Now, the epidermis is the layer of skin we see. This is this part over here on the outside, and it is made up of 5 or 6 even smaller layers of tissue. There are no blood vessels or nerve endings in this layer. This is the outer bit, the part that you can feel with your fingers. Back part of your fingers is the outer bit. Cells on the surface are constantly shedding and being replaced with new cells that grow and arise from a deeper region called the stratum basale every 2 to 4 weeks. So you don't need to go for a facelift on a regular basis because nature is providing that for us. Because every 2 to 4 weeks, we're getting a new layer of skin. The outermost layer is a layer of dead cells called the stratum corneum, which are flat, scaly, keratinized epithelial cells. Please don't worry about all these big fancy terms over there. And if you really had to take your skin and put it under a microscope, I think it could be quite scary, because when you magnify this, what we see on the outside, right down to those little scales, it's fascinating, but also quite scary. You slough off about 500 million cells every day, or about 0.6 kilograms or 600 grams of dead skin a year, allowing for rapid repair in case of injuries. I really don't know who did all the calculations on this, but good luck to them. Now, your skin color can indicate disease. So it's not just an organ that looks good, but it also is a sign. Once again, listen to your body, watch your body for various signs. Yellow skin, otherwise known as jaundice, may indicate liver disease. And we all know of babies who are born and they usually after a day or so are known as being jaundiced and have to end up going under ultraviolet lights or infrared lights or whatever it is for a few days. And also people who have got problems with their liver, like cirrhosis of the liver, they end up with this yellow skin. And you'll find that really bad alcoholics often have this yellowy, leathery, hard skin because of the damage to the liver. In liver disease, the body can't break down bilirubin. And a buildup of the bilirubin, which is your red blood cells, just by the way, gives the skin the yellow color, almost like rust. Yellowish color may also be seen in the whites of the eyes, and this is classic in jaundice or liver failure. Bronze color may indicate adrenal gland disease, or malfunctioning adrenal glands can cause the skin to produce excessive melanin. So this is not just on people who spend an extreme amount of time outside in the sun. That can also mean not just that they've got a healthy tan, but that they've got problems with the adrenal glands. Bruised skin could indicate skin, blood, or circulatory problems. So we all know that if you break a bone or you have a high impact on your body, you end up with a bruise. We can understand those bruises, but if you just suddenly develop bruises for no reason, it's time to have it checked out, because that is an indication that there's a problem somewhere with your skin, with your blood, or with your circulation, or all three. We'll start at the dermis, and this is the layer below. So that was all the epidermis. Now we're getting to the dermis, which is the layer below or inferior to the epidermis. And this is a slightly thicker layer. And it contains the following. It contains capillaries, collagenous or elastic fibers, involuntary muscles, and those are the muscles that work whether we think about them or not, like your breathing or your heart. You can't stop your heart by thinking about it. You can control your breathing to a certain extent. You get the shivers. That is all your involuntary muscles. And there's also a lot of nerve endings in there, as well as lymph vessels. and then the hair follicles, or the roots of the hair. And then you have a thing called pseudophorus glands, or also known as sweat glands. And then you also have the sebaceous glands, which is the oil glands. You have small fingers of tissue that project from the surface and anchor the layer to the epidermal layer. So think of Velcro. I don't know about you, but I work with Velcro on pretty much a daily basis. I hate the stuff, but I also love it because it works so effectively. And most medical appliances have Velcro, and most of our straps have Velcro. So if you think about the epidermis attaching to the dermis with Velcro, you'll get a better idea of how these things work. The finger and toe prints arise from the dermis layer. So technically, your fingerprints are coming through the outer layer of the skin. Nerve fibers allow you to sense what is happening in your environment. So you can sense, are you getting cold? Are you getting hot? Is the stove that you're touching too hot, too cold, whatever? And this is where those nerve fibers are, in the dermis. And vasodilation of capillaries in this layer causes blushing. And I don't really know why, but we all know what a blush is, and in some cases we know how to cause that as well. Now, collagen and elastic fibers allow for the elasticity of the skin, namely this pull that you can go over here. Don't have too much of elasticity in my forehead, and some areas have got less elasticity, but if I take my arm, for instance, and I pinch it and pull like that, that's the elasticity in the skin. And if you do that and it stays like that, it's an indication that you're dehydrated, just by the way. And this prevents the tearing with movement. So imagine if we didn't have that elasticity and you stretched or you moved, your skin would tear like soft tissue paper. And it wouldn't go back. So we need to have that elasticity to prevent the tearing with movement. And it also allows the skin to return to normal shape during periods of rest. Older people lose some elasticity, and this leads to wrinkles, those little things around the eyes and on the forehead and in various other places around the body. So your pseudophorus, or your sweat glands. And there are two main types of these glands. The apocrine sweat glands secrete at hair follicles in the groin and the other nether region, as well as the armpits. And they become active around puberty and are believed to act also as sexual attractants. So it's quite an interesting one over there. The eccrine glands are found in greater numbers on your palms, your feet, your forehead, and upper lip. And these are important in regulation of temperature. So when you get very hot, remember what happens there? Or if you think about what happens to you when you get very hot, your palms get sweaty, your feet get sweaty, you have sweat on your brow, and quite often you have sweat on your upper lip. But you don't always have as much sweat on the rest of your face or your body. Now, the body has around about 3 million sweat glands. You want to go and verify that, feel free to count, but I'm not going to be counting them. Now, sweat on its own has no odor, but bacteria degrades substances in the sweat over time into chemicals that give off strong smells, commonly known as body odors. So if somebody is perspiring a lot, they're not going to smell bad. It's only when that perspiration, when the bacteria in that perspiration breaks down substances in the perspiration, that you get that nasty body odor smell. So this is where and how they look. So if you want to really do a microscopic look at your skin, this is what it looks like. It's actually a very holy little thing. So it's not a smooth layer like you would think it is. But, oops, where's my cursor over here? So you've got these little sweat pores very close to where the hair comes out. And this is where they run down like little tubes into a little reservoir at the bottom. and you've also got your little blood vessels going into the hair to keep it alive. And there's your sweat ducts over there, and your apocrine sweat gland over there, and you get all the deeper bits and pieces, the fatty tissues, etc. But we won't get too technical there. Now, the sebaceous glands play an important role by secreting oil or sebum. And sebum keeps the skin from drying out, and due to its acidic nature, helps to destroy some pathogens on the skin's surface. Again, the skin is a filter. So if you've got these bugs that sit on your skin and they're allowed to go forth and multiply, and you get a little cut in your skin, they're going to go in there and cause an infection. So what happens is nature produces this acid almost to really destroy the bacteria that's sitting on your skin. So we've got quite an impressive little defense system going over there. The subcutaneous fascia is the innermost layer of skin, or the hypodermis, and it's composed of elastic and fibrous connective tissue and fatty tissue. Lipocytes, or fat cells, produce the fat needed to provide padding to protect deeper tissues of body and act as insulation or temperature regulation. And I think that's probably part of my problem, is that, like when I go to places like the Eastern Cape that don't know how to keep their fridge doors closed, my padding isn't really sufficient to keep that cold at bay anymore. So that's why we prefer to be down here at the coast. Now, the fascia attaches to the muscles of the body. So now we're going to get into a couple of the diseases or problems that you'll find in the skin. And my apologies for some of the pictures. It can be a little bit graphic, specifically just after supper, but it's interesting nonetheless. So the first one is a thing called herpes. I think most of us have heard of herpes. And this is a lifelong viral infection that produces clusters of small fluid-filled sacs, or otherwise known as vesicles or blisters. And this is what it looks like, not even microscopically, but just if you use a magnifying glass and zoom in, this is pretty much what they look like. Signs and symptoms usually come and go, but stress and other diseases can temporarily decrease the immunity and lead to a symptom flare. So herpes, once you've contracted it, is always there. If your immune system is working well, it will keep it suppressed, but it's always there. And this is why when you get stressed, your immune system drops and you develop things like fever blisters. It's part of the herpes virus. You get different types of this virus as well. There's the herpes varicella, also known as chickenpox, and I think pretty much everybody in here is familiar with that. If you haven't had it, as a child, you probably know of children who have had it. And it can be spread by airborne particles or direct contact. Remember the chickenpox parties? Vesicles can be found on the face, the trunk, and extremities. And as we know, they can get rather itchy, and this is what leaves the telltale scars on somebody's face, is if they were very naughty and didn't listen and scratched those itchy bits, and that's where the scarring develops. Vesicles are associated with intense itching. Now, there is a classic fever blister. This is your herpes zoster, also known as shingles. This is another different version of it. And my elder sister would probably be able to tell you a little bit more about shingles, as she tends to stress a lot. And when she was writing her matric exams, she had shingles of note throughout her exams because of her stress. And it develops when dormant chickenpox virus reactivates. It causes extremely painful blisters or rashes that follow the course of a sensory nerve. This is why they are so painful, because they follow the nerve line. The symptoms develop when stressed, or disease, or trauma, or aging prevent the immune system from keeping the virus in check. And I've met a few people over the years who either under intense stress because of exams or things like that, or after major trauma or surgery, which is also trauma, have then developed these shingles. And it's not a fun combination to have. Then there's herpes simplex type 1, which causes cold sores or fever blisters around the mouth or nose. I do sometimes get them on the side of my lips over here, and I know my wife does as well, and I think both of my sisters also tend to get them from time to time. Commonly develops after a common cold or fever. I know mine happen usually when my stress levels are rising, and then I know I've got to sort of stand back a little bit, breathe, and cut back on the stress and get it under control. And then you get your herpes simplex type 2, which causes genital herpes, which is in the nether regions. And this is spread by direct contact. It's most contagious when in its active stage. However, it can also be spread during remission. Unfortunately, viruses often tend to be a law unto themselves, and they tend to not listen to the books, but they tend to do things when and where and how they want to do it. Then we're going to go into the human papilloma virus quickly before I finish this off, otherwise known as HPV. This causes warts, which are also known as verruca, which is a hypertrophy of the keratin cells in the skin. And you get different types of warts. And these include things like common warts, which are usually found on children's hands and fingers. So the school teachers out there will know what I'm talking about there. And it's spread by scratching and direct contact, not by playing with frogs. They often disappear on their own. Then you have the infamous plantar warts, which are found on the sole of the foot. And if you've ever had a plantar's wart, you will understand that it can be extremely sensitive and painful. Part of the problem there is if you have a wart on your finger or your hand, it can expand outwards, whereas under your foot, because you're standing on it, it can only go out so far, and then it gets forced back in. And that's why they get so very, very painful. Also, they tend to grow inwards. Again, because it's under the foot, they get pushed back all the time. They have a relatively smooth appearance on the surface, but they do have a little bit of a, almost like a crater around them. And this is how you can diagnose the difference between a plantar's wart and a simple callus formation under the foot due to a different reason. I do see these from time to time. And it obviously causes pain when walking, and especially if it's an area where you're going to be putting a lot of pressure when you toe off or when you push off with your foot. There are certain areas in the foot that take more stress and strain than others. And if your plantar wart is there, you are going to have a lot of discomfort. Treatment includes removal by surgery or freezing. Now, most times your GP will start by trying to freeze them off. And if that doesn't work, then they go to surgery, which also sadly isn't always that effective. And what I'm going to say now is not medical advice, and no doctor will tell you this either, but unofficially, quite a few of them will tell you about it. Duct tape works quite effectively on plantar warts as well. Nobody has ever really been able to figure out how or why they work, just that they do work. And you take a strip of genuine duct tape, the nice hard one, the plasticky one with the thick glue and the tape that tears quite easily, and you stick that over your plantar wart, and you do not remove it. If it falls off, you put another piece on. And usually after about 2 weeks, that plantar wart tends to dry up and fall off naturally. We don't know why. We don't know if it's suffocated or if it's because of a reaction with the glue in duct tape, but for some reason or other, it seems to work. I'm going to stop there because we've got only about 6 minutes left. I'll get into the rest of these goodies next week. Does anybody have any comments or questions before I stop the recording? Please feel free to unmute.
If I can ask something, please, Sean.
Yeah, go for it.
Some time ago, I used to go to the Christchurch. Oh, sorry. Off. You mustn't put that on. And there was a gentleman, his whole face was like that, almost like marbles.
Mm-hmm.
And would that be the same?
No, that could be caused by a few different things. So one would have to really check and see what they call the pathology of those marks. It's probably not warts, but it could very well be an indication of some other underlying medical condition. Maybe he was exposed to...
I was wondering, was born like that or
generally
only...
not.
Okay. The only positive thing about that, don't have to shave.
Yes.
Any beard or anything like that,
Yeah.
which is a blessing, because I can't imagine shaving with a face that would be very...
Yeah. All right.
Thank you.
Not a problem. Let me stop recording.